Okay, here we are graphing polynomials, putting together everything we know about polynomials. This has been our ultimate goal, is to graph these guys. So we've got this guy here. First thing we want to figure out is the leading coefficient, the number right here in front, which is 3. Next is our degree. We add up all of our little exponents. I've got 2 plus 1 is 4. So I've got even degree with a positive. Don't care if the leading coefficient is odd or even. Only care if it's positive or negative. Positive leading coefficient, even degree. Our end behavior is both arms go up. Okay. We find our roots and the multiplicity of each root. Each root comes with the multiplicity. The roots are whatever is after the minus in each factor. So this root is 5. His multiplicity is the little exponent that goes with him, a 2. This root is negative 2. You have to think of that as x minus negative 2. Little exponent there is 1. This root is 4. Remember, it's x minus the root. Whatever is after the minus, his little exponent is 1. Notice, by the way, 2 plus 1 equals 4. That's your check. Add up all the multiplicities to get the degree. Now we determine if we're going to bounce or pass at each of these. Don't care if the root is odd or even. Care if the multiplicity is odd or even. This root, 5, has an even multiplicity. We'll bounce at that spot. These guys are both odd multiplicities. We'll pass through. Bounce at 5, pass through at the other two. Okay, we're ready to start graphing. Okay, so my end behavior is both arms up. I like to just go ahead and put my arms going up to begin with. My roots are 5, negative 2, and 4. So that means my x-intercepts are the points negative 2, 0, 4, 0, and 5, 0. I like to list these in order. It's going to make things easier. So negative 2, 4, and 5. Negative 2, 0, 4, 0, and 5, 0. Okay, now we just basically connect the dots. Go left to right. We're always going from left to right. I'm here on this arm. I'm coming along this arm. The first thing I have to hit is this x-intercept here. So I'm going to come down and connect up to that x-intercept. Now what do I do when I get there? Am I going to bounce off? Or am I going to pass on through? Those are the possibilities. I don't mean bounce backwards like this. That would not be a function. When I say bounce, I mean bounce back up, like a ball coming down, hitting the ground and bouncing. Or do we pass straight through? Well, over here I said at negative 2 I'm supposed to pass through. So I'm going to pass on through. So now I'm here. I look and say, what's the next thing I have to hit? Well, I have to hit this x-intercept here. So the graph is going to have to come down and turn around to come back up here. It can't pass over here. There are no x-intercepts in here. The graph has to dip down and come back up to that x-intercept. Now what do I do when I get there? I'm at 4. At 4, I'm supposed to pass on through. So pass on through. The next thing I have to hit is this 5, this intercept at 5. And at some point, I'm going to have to connect up to this other arm over here. So if I came and hit this x-intercept and passed through, there's no way to connect up to the arm because I can't come through the x-axis anymore. I've plotted every x-intercept. But I don't have to worry about that. I'm going to bounce at 5. So I come over, I touch the 5, and then because of the even multiplicity, I'm going to bounce off the x-axis. I connect up my other arm. One last thing we have to find is that y-intercept. How do we find the y-intercept? Same way we always do. We plug in 0. So I'll get 3 times 0 minus 5 is negative 5 squared. 0 plus 2 is 2. 0 minus 4 is negative 4. I'm going to throw that in a calculator. And I get negative 600. Now we could, if we wanted to, go negative 1, negative 2, all the way down to negative 600 and draw this graph really, really low down here. Or, nobody said we had to use the same scale on the x and y axes. You know where negative 600 is? It's right there. Right there, because I said so. Negative 600. So the y-intercept is the point 0, negative 600. And that graph is done. Now, if you were to type this graph into some graphing software or maybe your graphing calculator, you'll see that maybe we didn't get everything right. I don't know how high this little crest here comes. I have no idea. I don't know if there are extra dips. Maybe the graph actually has a big old dip right here. We have no way of finding that stuff without calculus. So this is just a rough sketch of the graph. And it's pretty good. When you get to calculus, you fill in more details. You figure out how high this is going to go, if there are extra dips or valleys in here, and so forth. Okay, another example. Same exact steps. First thing we do is list the leading coefficient, the number here in front, negative 7. We find our degree by adding up all the multiplicities, 3, 4, 5, 6, 7. I have an odd degree with a negative leading coefficient, so my end behavior is the left arm goes up, the right arm goes down. Negative leading coefficient, the right arm has to go down. Because I have an odd degree, they have to go opposite ways, so since this one went down, that one must go up. So my end behavior is up, down. I find all my roots and the multiplicity of each root. Okay. Now it actually makes things easier when you're writing out your roots here if you do them smallest to largest. In this case, I wrote them out smallest to largest. But it does help. So you always want to look through and see who's the smallest root and so forth. So the smallest root here would be negative 4. His multiplicity is 3. The next one is 5, multiplicity of 2. 6 has a multiplicity of 1. There's a little 1 up there. And 7 has a multiplicity of 1. Let's check. 3 plus 2 is 5. Plus 1 is 6, plus 1 more is 7. Okay. All the multiplicities should add up to the degree. What are we going to do with each of these? Are we going to bounce or pass? Don't care about the root. Care about even and oddness of the multiplicities. Odd, we pass. Even, bounce. Odd, pass. Odd, pass. Okay, so our x-intercepts are the points negative 4, 0, 5, 0, 6, 0, 7, 0. We'll find the y-intercept in a minute. We will need him. Okay, we're ready to do a rough sketch here. Okay, so negative 4. 5, 6, and 7. There are my x-intercepts. Okay, I like to put in my end behavior. So I'm going to have an arm coming up this way, and then over here, an arm going down. And now we just connect the dots. Always go from left to right. Don't start trying to put in your little passes and bounces yet. Start over here at your arm. Connect up to the first thing we have to hit. We have to hit this x-intercept. What do I do when I get there? When I get to -4, I'm supposed to pass through. Pass on through. What's the next thing I have to touch? This x-intercept at 5, 0. So to get from here to there, I'm going to have to swing around and come back up to it. Once I hit that, what do? Do I pass straight through or do I bounce under? Pass would look like this. Bounce would look like this. Bounce. What do? Well, I told myself I was supposed to bounce, so let's bounce off. When I say bounce, I don't mean bounce backwards like this. That would not be a function. Bounce looks like that. Imagine throwing a ball, hitting the ceiling, and it bounces back off. Now I have to turn around to get back to this next x-intercept, so I'm going to have to swing around and touch him. What do I do when I get there? At 6, I'm supposed to keep going through, pass through, swing around and hit at 7. At 7, I'm also passing through. And hey, look, I get to connect up to my other arm. Okay, the only thing left is the y-intercept. To find the y-intercept, we plug in 0. G of 0 would be -7. 0 plus 4 is just 4. 0 minus 5 is -5. -6. -7. Plug in 0 for all of the x's. And then just type this in a calculator. I'm going to grab my calculator. And I got -470,400. A big giant y-intercept. It's negative, of course. Hey, look! According to the picture, the y-intercept should be negative, and I got a negative number. Huh! Is that a surprise? No, it's not. So the y-intercept is the point 0, -470,400. And then we label that here on the graph. Nope, 0, 400. And we're done. Okay. We'll do a bunch of examples here. Okay, let's graph this guy. Our leading coefficient, the number in front, is 8. Degree. Add up all the multiplicities. 2 plus 2 is 4. We have even degree. So both arms are going to go the same way. Anytime you have even degree, the arms are either both up or both down. Because my leading coefficient is positive, they must both go up. Okay, we list each root and the multiplicity of that root. My roots are -4, who has a multiplicity of 2, and +4, who has a multiplicity of 2. 2 plus 2 is 4. The multiplicities always add up to the degree. Okay, so our x-intercepts are the points -4, 0, and 4, 0. We're ready to start graphing. So -4, 0, +4, 0. My end behavior is both arms are going up. I like to add those in before I start graphing. What am I going to do at each x-intercept? Pass or bounce? Multiplicities are even, so on both of these I'm going to bounce off. Bounce. So my graph will come in, hit this x-intercept, bounce off. I have to come over and hit this next x-intercept in order to get right here, from right here. The only thing I could possibly do is swing around and come down. Now that I'm there, somehow I got to connect to this other arm, and I'm supposed to bounce off, so the graph must do that. Notice these are nice and curvy, by the way. The graph's not coming in sharp V's. It's nice and smooth and curvy. The only thing left is to find the y-intercept. So we plug in 0. H of 0 will be 8 times 4 squared times negative 4 squared. So we type that in our calculator. And I got 2048. So the y-intercept is the point 0, 2048. And we say, okay, right there, that's a height of 2048. Okay, another example. Got a couple left here. We want to graph this guy. Our leading coefficient is 5, the number in front. Leading coefficient is a number. It's not 5x, it's just 5. The degree. Sometimes people will look and go, oh, 3 plus 2, 5. No, don't forget about this guy. That's another factor there. That x is not attached to that 5. The factors are x minus 3 3 times, x minus 6 twice. That's just the leading coefficient. That's another factor. I have to count him. So I've got 3, 4, 5, 6. Even degree, so the arms go the same way. Because my leading coefficient is positive, both arms go up. Okay, I list all my roots and the multiplicity of each. Here's where these get messed up. That guy right there is a factor. He gives me a root. What number makes x 0? 0. What's the little power on the x? A 1. What number makes this factor 0? 3. What's his exponent? 3. The root is 6. The exponent is 2. 1 plus 3 plus 2 equals 6. Okay, we're ready to start graphing. So my x-intercepts are 0, 0. Let's write that down. X-intercepts, 0, 0, 3, 0, 6, 0, 3, 0, 6, 0. My end behavior is both arms are going up. Okay, so I'm going to always start on the left and work your way right. I'm running along this arm here. First thing I have to hit is that x-intercept. What am I supposed to do when I get there? Multiplicity is odd, so I'm going to pass. At the next one, I'm going to pass. At the 6, I'm going to bounce. Odd multiplicities, pass through, even, bounce off. So the graph is going to pass through, right there at 0. The next thing I have to hit is this next x-intercept. What am I supposed to do when I get there? At 3, I'm supposed to pass through. I have to hit 6, so I'm going to come over and hit 6. When I get to 6, I'm supposed to bounce off. So instead of passing through, bounce off. Hey, connect up to the other arm, and we're done. Okay, now the y-intercept. This is a common mistake. Pay close attention here. The y-intercept, I'm plugging in 0 for all of the x's, even that one. So 5 times 0 times negative 3 cubed times negative 6 squared. That's 0. 0 times anything is 0. I already have the y-intercept. It's right there. Like I've already graphed the y-intercept. When one of your factors just has an x, you already know the y-intercept. You've already graphed it. It's the x-intercept also. The y-intercept is just 0, 0. You have to be careful there. That will cause some mistakes. Okay, one more. Okay, notice here I've got this guy here, this x squared in there. We've got to be careful with him. We're going to have a y-intercept of 0, 0 again. Okay, our leading coefficient is 8. Our degree, 2, 3, 4, 5. Add up all the little exponents. 2 plus 1 is 3, plus 2 more is 5. My end behavior. Odd degree, so the arms will go opposite ways, like this or like this. Positive leading coefficient, so the one on the right must be up. If that's positive, the one on the right goes up. Because it's odd degree, the other one must do the opposite, so it must go down. Opposite ways, because of odd degree. Okay, we list the roots and the multiplicity of each. I think things are much easier if we list out our roots smallest to largest. My roots here are going to be 0, -5, and 3, so I'm going to list the -5 first. He has a multiplicity of 1, so I'm going to pass. The next one would be 0. Has a multiplicity of 2, so I'm going to bounce. And 3 has a multiplicity of 2. I'll also bounce there. My x-intercepts are -5, 0, 0, 0, 3, 0. And we're ready to graph. Okay, so what do I need? I need to go back to -5, 0, and 3. There are my 3 x-intercepts. My end behavior. This side's down. This side's up. Now we just connect the dots doing our bouncing and passing. At -5, I'm supposed to pass. So I'm going to pass right through. I got to turn around to get to this next x-intercept at 0. And at 0, I'm supposed to bounce. I'm going to bounce up. Same thing at 3. I got to come over, hit the 3, and then bounce because I said bounce. Okay, so we get, looks like the Loch Ness Monster here. What about the y-intercept? I could go through a whole bunch of arithmetic, but I've already got it. It's right there. There's the y-intercept. Anytime you have an x in your factored form, x to any power, your y-intercept, it's just 0, 0. 0 times anything is 0. We're done. That's the graph. Okay, some other videos related to polynomials should be popping up right now. Click on those for more information.